So here's a big question for you. Are we alone in the universe?
Ooh, starting with an easy one, I see. Hello, everyone, and welcome to the English Science Podcast. I'm Nicole.
And I'm Ben. And Nicole, I am so excited for today's topic. It's the one question that I think everyone, everywhere has asked at some point.
It really is, and that's what this podcast is all about, using these huge, exciting ideas from science and nature to help you improve your English. Today, we're going on a journey to find alien life.
So let's dive right in. What even is simple life? Are we talking about little green men?
Not quite. When scientists talk about simple life, they mean tiny things like bacteria or other microorganisms, the kind of life that got started on Earth billions of years ago.
Right, so we're not expecting to find aliens walking around. We're looking for the smallest, most basic building blocks. So where's the first place we should look?
Well, the most famous candidate is our neighbor, Mars.
Of course, the red planet. I feel like we've been talking about life on Mars forever, but there's a good reason, right?
Absolutely. We have strong evidence that Mars used to have rivers, lakes, and maybe even an ocean. There's still a lot of water ice at its poles and underground.
Yeah, and that's why we send rovers like Perseverance there.
Exactly. Perseverance is like a robot geologist. It's drilling into rocks that formed in that ancient water, looking for biosignatures.
Biosignatures. That's a great vocabulary word. It just means signs of life, right? Like specific chemicals or fossils of tiny microbes.
You got it. It's a space detective searching for clues left behind billions of years ago.
A space detective. I love it. But Mars is kind of cold and dry now. Are there places that are more active?
Oh, I'm so glad you asked. This is my favorite part. We need to look farther out to the moons of Jupiter and Saturn.
Okay, tell me more.
So, Jupiter's moon Europa and Saturn's moon Enceladus are both covered in a thick shell of ice. But underneath that ice, scientists are almost certain there are huge global oceans of liquid salt water.
Whoa, so miles of ice and then a hidden ocean. How can it be warm enough way out there?
It's called tidal heating. The massive gravity from Jupiter and Saturn constantly squeezes and stretches these moons, which creates friction and heat inside, enough to keep an ocean liquid.
Wait, so you're telling me that Jupiter's gravity is basically churning the inside of Europa like a dough mixer, and that's what's keeping it warm? That's wild.
Exactly. And on Enceladus, we've actually seen proof. The Cassini spacecraft flew through giant geysers, plumes of water vapor and ice particles shooting out from cracks in the ice straight into space.
You're kidding. So we've basically sampled its ocean.
We have, and we found salt and simple organic molecules, the very things you need to build life. It's one of the most exciting places to look.
Wow, okay, my mind is blown. An underground ocean with heat and organic stuff. That sounds promising. Anywhere else?
One more really weird place, Titan, Saturn's biggest moon.
What's so weird about Titan?
Well, it's the only other body in our solar system with a thick atmosphere and liquid on its surface. It has lakes, rivers, and even rain.
That sounds a lot like Earth. What's the catch?
The catch is, it's incredibly cold. The liquid isn't water, it's liquid methane and ethane, like natural gas.
So, life there wouldn't drink water, it would drink methane?
Possibly, scientists call this life as we don't know it. It would have a completely different chemistry. It's a long shot, but it makes you think about how creative nature can be.
Okay, so to recap this part, Mars had the right conditions in the past. Europa and Enceladus might have them right now in their hidden oceans, and Titan could host a totally different kind of life.
Perfect summary. We have all these amazing possibilities, these tantalizing clues, but as of today, no definitive proof. The search continues.
Okay, so that's simple life inside our solar system. But what about the big question? Complicated life, intelligent aliens, the kind we see in movies.
Right, the ET question. For that, we really have to look beyond our own solar system to other stars. We call planets orbiting other stars exoplanets.
There are a lot of them, right? I heard a number that was just astronomical, literally.
It is. Our galaxy, the Milky Way, has hundreds of billions of stars, and we now believe that most of them have planets. So we're talking trillions of planets in our galaxy alone.
Trillions. That's a number my brain can't even process. So how do we narrow it down? We can't check them all.
We start by looking in the habitable zone. It's sometimes called the Goldilocks zone, and that's just our galaxy. There are hundreds of billions of other galaxies out there. The number of potential homes for life is just staggering.
Ah, because it's not too hot, not too cold, but just right. Okay, now my brain really hurts, in a good way.
Exactly. It's the region around a star where the temperature is just right for liquid water to exist on a planet's surface. And we found lots of rocky, Earth-sized planets in that zone.
Okay, so we found potential Earths, but how can we possibly know if there's life on a planet that's light years away? We can't send a rover there.
We can't, but we have amazing tools like the James Webb Telescope. It's like a giant time-traveling detective in space.
A time-traveling detective? How does that work?
It analyzes the light from a star after it passes through an exoplanet's atmosphere. The chemicals in the atmosphere absorb some of that light, leaving a kind of fingerprint.
A fingerprint in the light. That's so cool. What kind of chemicals are we looking for?
We're looking for biosignatures again, but on a bigger scale. Things like oxygen, methane, and water vapor all at once. On Earth, our oxygen-rich atmosphere is created by life, by plants and algae. So finding oxygen on another planet would be a huge clue.
So the James Webb Telescope is basically sniffing the air of other worlds from trillions of miles?
That's a great way to put it. But there's another way to search too, one that looks for intelligent technological life.
You mean listening? Like for alien radio shows?
Pretty much. This is the goal of projects like SETI, which stands for the Search for Extraterrestrial Intelligence.
Right. They use massive radio telescopes to scan the stars for any signals that don't seem natural. A signal that's structured or complex could be a sign of technology.
Exactly. It's based on the idea that any advanced civilization would probably discover radio waves, just like we did, so maybe they're broadcasting something.
It's a bit like searching for a needle in a haystack, isn't it? A cosmic haystack.
It is. It's a huge challenge. We've been listening for decades with no luck, but the universe is vast and old. We've only just started to listen. Who knows what we might hear tomorrow?
Wow. Okay, so let's take a breath and recap everything we just talked about. It was a lot, but it was so cool. That actually brings up a really interesting and slightly spooky idea. It's called the Fermi paradox.
It really was. So first, we talked about simple microbial life right here in our own solar system.
Right. We have Mars, which was once wet and could have ancient fossils, and then the icy moons, Europa and Enceladus, which might have warm, salty oceans right now, hidden under the ice.
With those amazing geysers. And don't forget weird and wonderful Titan, where life could be based on methane instead of water. Lots of possibilities, but no proof. Yet.
Yet. I like that. And then we zoomed way out, beyond our solar system, to look for complicated or intelligent life.
We did. We learned that there are trillions of planets in our galaxy, and many of them are in the Goldilocks zone, where liquid water could exist.
And with incredible tools like the James Webb Space Telescope, we're sniffing their atmospheres for signs of life, like oxygen. It's cosmic detective work.
Totally. And at the same time, projects like SETI are listening patiently, hoping to catch a radio signal from an alien civilization.
It really makes you feel both incredibly small and incredibly hopeful at the same time.
That's the perfect way to describe it. And you know, this is exactly why we started the English Science Podcast. Learning a new language can feel hard, like a chore. But when you're talking about alien oceans and cosmic detectives, it becomes an adventure.
Exactly. You're not just memorizing words, you're exploring huge ideas. Every new word, like biosignature or exoplanet, is a key that unlocks a new part of the universe. It's like building a muscle. You don't see the change after one day, but every time you listen, you get a little stronger, a little more confident.
And we want all of you listening to feel that excitement. Don't worry if you didn't catch every single word. The point is to listen, to be curious, and to enjoy the journey. Every episode you listen to is a huge step forward in your English skills. You've got this.
Absolutely, you really do. And if you enjoyed this cosmic adventure with us, please help our channel grow. Hit that subscribe button so you never miss an episode.
And give us a like if you learned something new. It really helps. Also, we want to hear from you. Drop a comment below. Tell us why you want to improve your English, or which science topic totally excites you.
Yeah, let us know. We have 2 big questions for you to answer in the comments below. What's the hardest part of learning English for you?
And which topic should we cover in a future episode? Dinosaurs, black holes, the future of AI? Let us know.
And one last thing, to help you practice, we've put 10 questions about today's episode in the description box below. It's a great way to test what you remember.
Great idea, Ben. Okay, that's all from us for this episode of the English Science Podcast.
Keep learning, stay curious, and we'll talk to you next time.